Yaskawa.
The Technical Training Department of Yaskawa America Incorporated presents Adding and Configuring the Modbus TCP/IP Option Card for Yaskawa 1000 Series Drives. Hi, I'm Steve Kaler. An option card can provide a communications connection between a drive and a Modbus TCP/IP network, facilitating the exchange of data. In this program, we are going to examine the key steps to establishing network communications using the SIEM3 option card for 1000 series drives. Specifically, we'll explain and demonstrate how to install the SIEM3 option card, how to select your network topology for use with this option card. We'll explain what RTSP protocol is and how to set it up on the network. We'll configure the Yaskawa Drive to accept and follow network commands. We'll set up the PLC to communicate with the drive. And after that, we'll enable RTSP, and we'll wrap up things with a series of troubleshooting techniques. At the end of each chapter, we're going to ask you a few questions to review some of the major points we've covered. Are you ready? Let's get started. Installing the option card. Let's look at Yaskawa's SIEM3 Modbus TCP/IP network card and the other items needed to put it to use. First, you'll need a Yaskawa drive that is capable of accepting the Modbus option card. The majority of Yaskawa's 1000 series drives are designed to readily accept these cards. You're also going to need one of the 4 available Modbus TCP/IP option kits. There are 2 different types of Yaskawa drives that the Modbus TCP/IP option board can be installed into. We will refer to the A1000, P1000, IQ Pump 1000, and Z1000 as a standard size drive, and the V1000 as a micro-sized drive. For the standard-sized 1000 series drives like the A1000, you'll use either the SIEM3 or the SIEM3D. The D signifies the dual-port version. For the micro drive, V1000, you'll use either the SIEM3/V or the SIEM3D/V. Because they have dual ports, the SIEM3D and the SIEM3D/V option cards allow you greater flexibility in network topology. We'll talk more about that later. Now, the first step to installing a Yaskawa Modbus TCP/IP option kit is to take a closer look at its contents. A typical kit contains the option card itself, plus the items necessary to connect it to the network. These include a ground cable, mounting screws, and an installation manual. Now, a close examination of the card itself reveals a few important parts. There will be a connector with either 1 or 2 female RJ45 ports, depending on the card you're installing. Now, just beside this connector is the card's ground point. Elsewhere on the card is a sticker showing the Yaskawa part number, and this part number is an easy reference point to make sure that you have the correct option card. Many of the Ethernet-based option cards look similar, and the easiest way to differentiate them is by part number. Installing the option card into a drive is designed to be a quick and easy process. The installation procedure varies based on whether you are installing the card in a larger-sized standard drive, a smaller-sized standard drive, or a micro drive. We will address all 3. First, let's consider the larger-sized standard drives. With the drive unpowered and the bus capacitors fully discharged, remove all of the sheet metal cover plates except the top one. Remove the keypad, then loosen the captive screw that secures the plastic cover shielding the control board. Now remove the plastic cover. Locate the CN5A serial port on the control board. Line up the connector on the back of the option board, then press the board down into the serial port. Secure the screws that hold down the board with the left screw also attaching the blue ground wire to the board. Connect the other end of the ground wire to the ground terminal located to the left of the board. All of this is covered in the installation guide that comes with the option kit and is also available on the Yaskawa website. Reattach all of the covers and apply the decal to the cover plate as described in the installation guide. Installation in the smaller standard size drives follows much the same procedure, but the cover to the smaller drives is split in half, with both covers needing to be removed. The process to install the option board into a micro drive can also vary based on size. It follows the same basic procedure as the standard size, except that the option board comes installed in a carrier that will replace the original cover of the micro drive. The basic steps are: remove power and allow the bus capacitors to discharge. Remove the covers. Attach the ground wire to the micro drive ground terminal. Route the ground wire through the option cover and connect it to the option board. Install the option board and carrier, and then replace the covers. Specific steps can be found in the installation guide. At this point, we should be ready to apply power to our drive with our option board installed. After power is applied, diagnostic LEDs on the card may illuminate depending on the card's current status. Refer to your installation manual for an explanation of the status of the diagnostic LEDs. Now, before you attempt to run the drive from the network, test run the drive in local mode. Once you establish that the drive itself is running correctly, you can proceed to program the drive to accept commands from the network. Well, before we continue, let's review what we've learned so far. Let's take a moment to answer the following questions. Question number 1. What does the letter D stand for in the Yaskawa part number SIEM3D? The answer is the letter D in SIEM3D signifies that this is a dual port option card. All right, question number 2. How do you ground the Modbus TCPIP card? To ground the Modbus TCPIP card, attach the blue cable from the option kit between the drive's ground terminal and the option card mounting screw. And question number 3. Should an option card be installed or reseated while a drive is powered? And of course the answer is no. Option cards should never be installed or reseated while a drive is powered. Chapter 2. Selecting your network topology. Setting up a network requires the use of Cat5 cabling. In general, 3 network configurations or topologies are possible. The first of these network topologies, the star or tree, requires the use of an Ethernet switch or multiple Ethernet switches. With this topology, the dual port option card is not required. The other network topologies, line and ring, do not require the use of an Ethernet switch or switches. However, both do require the use of a dual port option card. RSTP is possible only in the ring configuration. Now, before we go any further, let's define the acronym RSTP. RSTP stands for Rapid Spanning Tree Protocol. RSTP is a Layer 2 protocol allowing for redundancy in ring networks while reducing the need for switch hardware and some cabling. It also provides detection and recovery of faults in the ring. If a communications break occurs somewhere in the network, connectivity is still maintained. RSTP is only available with dual port versions of the option card. RSTP can be enabled on Yaskawa's SIEM3D and SIEM3D/V option cards using the option card webpage. Now, before we set up the RSTP network, we need to make sure that at least one device has RSTP enabled. This needs to be done prior to connecting and powering on all devices in the ring. If we establish a ring without an active RSTP device, it may cause a loss of communication to devices on the ring. Now, let's briefly review what we've learned so far about network topologies. Question number 1. What type of cable is used for interconnecting an Ethernet network? And the answer is Ethernet networks are connected using Cat5 cables. All right, question number 2. What does RSTP stand for? That's right, RSTP stands for Rapid Spanning Tree Protocol, a Layer 2 protocol allowing for redundancy in ring networks. And finally, question number 3. Which network topology will benefit from RSTP? Star, line, or ring? And the answer is the ring. Ring networks benefit from RSTP. Chapter 3, Configuring the Drive. The network configuration parameters for any Yaskawa Ethernet option card are located in the drive's F7 parameter group. If you want the network to assign your network settings, program F713 to either 1 for boot P or 2 for DHCP. If you want to use a static network IP address, set F713 to 0 for user-defined. You will then need to use F701 through F704 to set your IP address, F705 through F708 to set your subnet mask, and F709 through F712 to set your gateway address. Cycle power to the drive for the new network configuration changes to take effect. Confirm the network configurations by viewing monitors U680 through U691. From this point forward, the card will only be accessible using this new network configuration. Use a Cat5 cable to connect the drive to your network. One advantage of the Ethernet-based option card is web access. The card can provide a web interface when queried with Internet Explorer or other common web browsers. To pull up the web page, type the IP address shown in monitors U680 through U683 into the address bar of your browser. When the connection is successfully made, the card's web page will be displayed. The web page displays details about the card, including its MAC ID, firmware version, IP address, and I/O diagnostics. There are additional web pages that offer further diagnostics. An important step that is sometimes overlooked is configuring the Yaskawa drive to follow the frequency reference and run commands that are sent to it over an Ethernet network. To properly configure the drive to follow network commands, set the frequency reference parameter B101 and your run command parameter B102 to setting 3, option PCB. All right, let's review what we've learned about configuring the drive with question number 1. Which parameter group in Yaskawa drives configures the network settings of the Modbus TCP/IP option card? And the answer? F7 is the parameter group in Yaskawa drives that configures the network settings of the option card. Question number 2. What must be done to the drive to make network parameter changes take effect? You've got that one. The network parameter changes take effect when the drive is cycled off and then on. And finally, question number 3, which monitors will always show the current IP address of the Modbus TCP/IP card? That's a tricky one. The monitors that will always show the current IP address of the Modbus TCP/IP card are the U680 through U683. Chapter 4, Setup for Network Operation. So now that we've installed the Modbus TCP/IP option card, wired it to our network, and programmed the drive, we are ready to set up the PLC to communicate with the drive. To demonstrate this, we're going to use Schneider Electric's Unity software. We start by opening the Device Type Manager, or DTM browser, and we select our PLC. Then to add a node in the network, we right-click on the PLC's IP address and go to Add. We will select Modbus Device and then click on the Add DTM button. And we will name our first drive, drive number 1. Next, we go back to the DTM browser and double-click the PLC address, which brings up this screen to view network parameters. In the device list, we see the device, drive 1, we just added, and click on it. We will use the Address tab to change the IP address of drive 1 to 192.168.1.20, which matches the static address programmed into the drive parameters F701 through F704 of drive 1. To add a request, we click on the Request Setting tab and click the Add Request button. This will establish an I/O connection between the drive and the PLC. For this example, we will change some of the PLC network timing by changing the health timeout or message timeout to 50 milliseconds. And we'll also set the repetitive rate, or how often the PLC is sending messages to the drive, to 20 milliseconds. We will define what information will be read from the drive by entering the address of the register that contains our output frequency, which is defined in the manual as 2005 hex. Due to a registry shift of 1, we will need to read output frequency at address 2004 hex, which converts to 8196 decimal. The read length is set to 1 because the register that contains our output frequency is 1 word or 2 bytes in size. Now we will define the information that will be written to the drive by entering the first address of the consecutive registers that contain our run command and frequency reference. The first address is defined in the manual as 1 hex. Due to the registry shift of 1, we will need to write the run and reference starting at address 0. Since we are writing to consecutive registers, we will change the write length to 2 and click Apply. We've now configured our request as to where to read and write the data, but we need to define what format the data will take. We can do this by going to Request Items, listed below drive 1. We click the first item and shift-click the second item to add both bytes for the output frequency register. We click Define Items. We change byte to integer, since that is the format of the data. We change the name to Output Frequency to be easily identifiable and click OK. Then we go to the Output tab, where we select the first 2 bytes for the command. Click to define these 2 items. This will be a word, and we're going to call it command. Then the last 2 bytes we're going to write to will be the frequency reference. So, select those 2 items and click on Define. Again, we change them to integer, and we're going to call it reference. Now, we're going to add a second drive. So, we repeat the steps for adding a drive. As you add additional drives, the setup procedure is identical with the exception of the device name and IP address. Each drive must have a unique name for the PLC and its own IP address on the network. We scroll through the list and select Modbus Device and add DTM. This will be drive 2. Now drive 2 appears in our list. We need to assign this drive a unique IP address, so we change this address to 1.22. And once again, we'll set the request settings just as we did for drive 1. Just as before, we will change some of the PLC network timing by changing the health timeout to 50 milliseconds. And we'll also set the repetitive rate to 20 milliseconds. Just like with drive 1, we will need to read the output frequency at address 8196. The read length is set to 1. We need to write the run command and frequency reference starting at address 0. Change the write length to 2 and click Apply. Once again, we go to Request, only this time under drive 2. And on the input side, we select the first 2 items and click Define. We make the data type integer and name it Output Frequency, then click OK. For the output, select the first 2 items for command and then click Define. This will be a word, and we will name it Command. Click OK. And the last 2 items will be the frequency reference. So we select those 2 items and click on Define. We make the data type integer and name it reference. Then click OK. Then click on Apply. And exit this screen. Finally, we're going to build the changes we made. Now we'll connect to the PLC. At the bottom of the screen, it shows we're connected to the PLC. The red different box indicates the project in the PLC is different than the open project. We select Transfer Project to PLC. Click the checkbox for PLC Run After Transfer so that it prompts you to put the PLC back into run mode after the project has been transferred to the PLC. And then click the Transfer button. Click OK to stop the PLC. After the transfer is complete, click OK to run. Time for another review. We'll see how well you remember some of the major points about setting up for network operation. Question 1. When configuring identical drives on the network, what must be unique to each drive? And the answer, when configuring identical drives on the network, the name and IP address must be unique to each drive. Question number 2. When configuring an add request, if it says read, what is doing the reading? The PLC or the drive? That's right. When configuring an add request, it says read, the PLC is doing the reading. And question number 3. When we set our output frequency request, what type of data did we set it to? Integer. That's right. The frequency request was done in the integer data mode. On to Chapter 5, Testing the Network Operation. Now, we should test and prove that our drives are configured correctly to receive a run command and frequency reference and return the output speed. To do this, go to the Project Browser pane and select Derived Variables. A pop-up window shows what variables have been defined in the network. Select all of the rows that contain data for Drive 1 and Drive 2 and right-click. Choose Initialize Animation Table to provide access to our defined data. Once the animation table pops up, expand all the rows so that we can view the inputs and outputs for both drives. In order to actually enter or modify the data, we need to click the Modification button. Now we can enter run commands and frequency references for both drives. Once we do, we can see that the output frequency of both drives will update and show the current output frequency of each drive, proving that our project setup was successful. Well, this was a relatively brief chapter, so we have just 2 review questions for you to answer. Question number 1. Which pane of the Unity software has the Derived Variables link? That's right, it's the Project Browser pane of the Unity software that has the Derived Variables link. And question number 2, what step is required before an animation table will allow you to enter values? That's right, before an animation table will allow you to enter values, the Modification button must be clicked. Well done. Welcome to Chapter 6, Enabling RSTP. If you plan on using RSTP for your Ring network, we recommend that you enable that feature in the PLC and in the option card. To enable RSTP in the PLC, we use the Unity tool. Start by double-clicking on the IP address for the PLC controller in the DTM browser window and click on Services. In the Communication window, you'll see the RSTP item. We change it from Disabled to Enabled and click on Apply. This will cause a new item, RSTP, to show up in the Services list. Click on RSTP to view the operation status. The only option to change here is the bridge priority. The lower the number, the higher the priority the PLC will have. In most cases, it's best to leave the bridge priority at the default setting so that the PLC is the root bridge. After entering the changes, we pull down the Build menu to build changes and transfer the project into the PLC. Once that's done, RSTP is enabled in the PLC. To enable RSTP on the option card, you will need to pull up the option card webpage. Click on the RSTP link and then change the STP RSTP field from disabled to enabled. This will help speed up the RSTP discovery process at boot up. Now your device should be configured to operate efficiently using RSTP. Well, let's take a moment to review enabling RSTP. Our first question: how is RSTP enabled in the PLC? The answer we were looking for is RSTP is enabled in the PLC by using Unity software. Question number 2: how is RSTP enabled in the option card? Answer: RSTP is enabled in the option card via the option card webpage. And question number 3: will a highest or lowest bridge priority make a device the root bridge? And the answer: a lowest bridge priority will make a device the root bridge. Chapter 7: Troubleshooting. If after completing the installation and programming steps, the drives in your network are not fully functional, use the following troubleshooting techniques to find out why. Troubleshooting must be performed by qualified personnel. Always keep safety first. Make sure that all Ethernet cables are securely connected throughout the network, and that there's no noticeable damage to any cables or connectors. A simple continuity check with an Ethernet cable tester is likely to reveal any wire breaks. With the drive unpowered and fully discharged, check to make sure that the option card is seated properly in the correct port and associated cabling is securely plugged into the option card. Apply power and observe the card's diagnostic LEDs. For a complete explanation of the proper status of these LEDs, refer to your installation manual. Improper grounding of a device on the network might also be the problem. To troubleshoot potential grounding problems, try checking the following 4 conditions that might be the source of the ground trouble. Make sure the device is grounded at the cabinet with a star washer. Run copper directly from the drive to the single-point ground. If there are multiple cabinets or machine sections, it may be necessary to install a copper braid between the cabinets. Check that the building ground rod installation meets specifications and local code. In some cases, noise cannot be eliminated, or a suitable ground cannot be made. In instances like these, a ferrite filter may be effective for cleaning up some of the noise and solving intermittent problems. Ensure that each segment is grounded with a single-point grounding connection. The option card ground connection must be installed. Checking the grounding with an oscilloscope can sometimes reveal a noisy ground connection that could be causing the problem. However, the oscilloscope isn't a perfect solution because using a scope to check a ground can be difficult. A slow scope of 300 MHz or slower is unlikely to yield any useful information. If the hardware troubleshooting checks out, you can troubleshoot the programming. If the drive doesn't seem to run correctly when prompted by the master, the settings of the reference and the run source parameters should be checked. Incorrect parameters will cause the drive to ignore any run commands from the master. Check the frequency reference command and the run command, B101 and B102 respectively. Also, make sure the network parameters, IP address, subnet mask, and gateway have been set to the proper values for your network. If the parameters are not set correctly, the drive will not accept commands or run at the intended speed. You can check the IP address of the drive by looking at the monitor U680 through U683. For the subnet mask, look at U684 through U687, and the gateway will be U688 through U691. Monitors U698 and U699 display fault codes, which are particularly useful in detecting the causes of communication errors. Further information on fault codes is contained in the installation manual for your option card. Well, for our final review, here are 3 more questions about troubleshooting your network connection. Question number 1. what drive parameters need to be adjusted for the drive to be able to follow, run, and reference commands that are sent via Modbus TCP IP? Answer: the drive parameters that need to be adjusted for the drive to be able to follow, run, and reference commands sent via Modbus TCP IP are B101 and B102. Question number 2. Where should you look for an explanation of the option card status LEDs? The answer to question 2. For an explanation of the option card status LEDs, check the installation manual. And for our final review question, what tool would be useful for detecting noise on the option card ground terminal? The answer is an oscilloscope. An oscilloscope is useful for detecting noise on the option card ground terminal. Well, we've come to the end of this training program, but it definitely isn't the end of our commitment to make Yaskawa drives and motion products the best in the industry. The commitment to quality continues in the way we work with our customers and with our vendors. It's in the way we train our associates. It means we deliver product on time, we answer questions quickly, and we never say we can't. Yaskawa quality is reflected in the effort our associates bring to work every day. To us, quality means doing everything we can do to make our customers, partners, and employees' experience a great one. We commit to that. We make it happen. We can because to us, it's personal.